Welcome to Green Dolphin Science, and welcome back for a new deep dive.
Hello. Yes, this is where we dive into the sources, the studies, the data.
And pull out the really interesting stuff for you. We do the digging so you get the insights.
Making sense of the science and why it matters.
And today we're literally going deep into the sewers, actually.
We are indeed. We're looking at a recent study just out early 2024.
And it's all about using wastewater analysis. Yeah, what goes down the drain to track novel psychoactive substances, NPS, in Australia.
It's a fascinating piece of work. It really shows how analyzing, sewage can give us these crucial insights, sometimes before anyone else really knows what's going on.
Before health alerts or big drug seizures even happen.
Potentially, yes. It acts like an early warning system.
And that's especially important for NPS, right? These are the newer, often synthetic drugs.
Exactly. Often analogs of known drugs, but with unpredictable effects. Less known about them. They're just harder to track through the usual channels.
So this wastewater approach is kind of cutting edge for monitoring them.
It really is proving to be. So today, we'll unpack this study. We'll look at what specific NPS they found.
How the trends changed over the year they studied in Australia.
And crucially, why this wastewater method is so valuable.
Okay, let's get into it. First up, the science itself. Wastewater-based epidemiology, WBE. How does it actually work for tracking drugs?
Well, the basic idea is surprisingly simple, really. People take substances.
Right.
Their bodies process them, metabolize them. These metabolites, or sometimes the original drug itself, get excreted mostly in urine.
And that all ends up in the wastewater system?
Precisely. It flows through the sewers to the local wastewater treatment plant.
Which collects everything from potentially huge numbers of people. Thousands, millions.
Depends on the catchment area, but yeah, it aggregates the input from a large population.
So scientists grab a sample from the treatment plant.
They do. They take representative samples over time, and then they use very sensitive analytical chemistry.
Like what?
Usually techniques like liquid chromatography, coupled with mass spectrometry or LC-MS, and that lets them measure the concentration of specific drug metabolites, or the parent drugs, in that wastewater sample.
And from that concentration, they can estimate how much of the substance the whole population served by that plant must have consumed.
That's the principle, yes. It gives a population-level estimate of use for that catchment area.
You mentioned this is particularly good for NPS. Why them specifically?
Well, think about how we normally track drug use. Surveys rely on people self-reporting, which
doesn't always happen, especially for illicit or new substances.
Right, or you track police seizures or hospital data. But NPS might be used by, smaller groups, or maybe the doses are low, or they haven't caused widespread health issues yet.
So they fly under the radar of those systems.
Often, yes. But WBE doesn't rely on reporting or seizures if people are using it and excreting it, even in small amounts.
The wastewater analysis can pick it up.
Exactly. The methods they use now are incredibly sensitive. This study mentions detecting things down to the sub-nanogram per liter level. Tiny amounts.
Wow. Okay, so it catches things others miss. Let's talk about this specific Australian study then. How did they set it up? What was the scope?
It was pretty ambitious. They collected samples right across Australia, all the states and territories. ACT, New South Wales, Northern Territory, Queensland, South Australia, Tasmania, Victoria, WA. Everywhere.
And over what time frame?
A full year. From February 2022 through to February 2023.
So they could see changes over time.
Definitely. And the scale was large, too. They sampled from up to 57 different wastewater catchments.
57. How did that break down?
20 were in capital cities,
Yeah.
and 37 in regional areas where they could access them.
And how much of the population did that cover?
They estimated it covered wastewater from up to 57% of the entire Australian population during the study. So a really significant portion.
That's a solid sample. What about the lab methods? You mentioned LC-MS.
Yeah, they used that. And they actually used two approaches to get the best results. One was solid phase extraction, or SPE.
What does that do?
It basically concentrates the substances from the water sample, which helps detect things present at very low levels.
Okay, boosts the signal.
Right. And they also use direct injection, which is better sometimes for quantifying substances when they're present at higher concentrations.
So covering their bases, and how many different NPS were they looking for?
They had a target list of 59 specific NPS compounds they screened for in each sample.
All right, so the big question. After all that collection and analysis, what did they actually find in Australia's wastewater?
Okay, so out of those 59 target NPS, they detected 20. 20 different substances showed up in the samples across the country during that year.
20. Were there some that were much more common than others? What were the frequently detected ones?
Yes, definitely. They highlighted 5 based on how often they were detected, especially in the capital city sites. The mean detection frequency gives a good idea.
Okay, let's hear them.
Top of the list, or near the top, was pentylone. Very high mean detection in capital cities, 65%. Then N N-DMP, that's N N-dimethylpentylone, also high at 60% mean detection in capitals.
Right.
Eutylone was found quite often too, 44% mean in capitals. Then there was phenibut. That one stood out with this 72% mean detection frequency in capital cities. Very widespread.
Phenibut, okay. We should come back to that one. And the 5th.
Pyrimethoxyamphetamine, or PMA, that was detected at 25% of capital city sites on average.
So a mix there. Some stimulants like the pentylones and phenibut, which is a bit different. And did you say there was a difference between the cities and regional areas?
Yes, consistently. NPS were generally detected more frequently in the capital city wastewater compared to the regional sites. Some were found in both, but the detection rates were almost always higher in the major urban centers.
Makes sense. Population density, perhaps. Were there others found less often?
Yeah, the study lists others that popped up, like mephedrone, methoxetamine, alpha-PVP, even a fentanyl analog, valoryl fentanyl. But these were detected much less frequently or only in certain locations compared to those top 5.
Got it. Okay, now this is where, for me, it gets really interesting. They tracked this over a whole year. Did they see changes in what was being detected? Any major trends?
Oh, yes. This is perhaps the most striking finding. The study captured a really clear and pretty rapid shift happening.
A shift in what?
In the types of NPS being used, at least based on the wastewater signal, they saw a significant drop in how often eutylone was detected.
Okay, eutylone went down.
And at the same time, they saw a big increase in detections of pentylone and this N N-DMP.
Wow, like one was replacing the other.
It strongly suggests that, yes, the timing was simultaneous.
Can you give us the numbers on that shift? How big was it, say, in the capital city?
It was dramatic. Eutylone started off pretty high. In February 2022, it was detected at about 65% of the capital city's sites monitored.
Okay, quite common.
But by February 2023, just 1 year later, that detection frequency had fallen to 30%.
A huge drop. So pentylone and N N-DMP filled that gap.
Absolutely surged.
Yeah.
Pentylone, for example. In April 2022, it was only detected at 25% frequency in the capitals. By December 2022, it hit 100% detection frequency in the capital city sites monitored for it, and it stayed at 100% in February 2023.
100%. From a quarter of sites to all monitored sites in, 8 months?
It's a remarkably fast change in the wastewater profile. N N-GMP showed a similar sharp rise. The study notes it first appeared, or was first reported in their results, I should say, in February 2022 at 13% frequency in capitals.
Okay.
And it reached 100% frequency in February 2023 at the sites monitored throughout that specific period.
So the data really points to pentylone and N N-DMP maybe being marketed or used as alternatives as eutylone became less available or fell out of favor.
That's the strong implication from the wastewater data, yes.
Yeah.
And the researchers note this isn't just an Australian thing. Similar trends, this eutylone to pentylone shift, have been seen in the U.S. too.
Suggest maybe a global supply chain thing or market forces playing out?
It could well be.
And was this shift just in the big cities, or did regional areas show it too?
The pattern was mirrored in the regional sites as well. Eutylone detections decreased. Pentylone detections increased over the year in regional wastewater too, although the overall frequencies were generally lower than in the capitals. The trend itself was consistent.
This really drives home that point about WBE being an early warning system.
Exactly. This study is a perfect case study for that. One of the key takeaways is how the wastewater detections lined up, or rather, didn't line up initially with other official alerts.
What do you mean? The wastewater saw it first?
That's what the data suggests. The study points out that official Australian drug alerts about pentylone linked to hospitalizations came out around February 2023.
Okay, early 2023.
And police seizures of N N-DMP were reported during 2022.
Right.
But this wastewater study was picking up pentylone and N N-DMP and their rising trend much earlier. In some states, they detected them as early as February 2022, right at the start of the study period.
So the signal was in the sewage months, potentially even a year, before it hit the headlines through hospital reports or police busts.
That's what this data indicates. It shows the potential for WBE to give health authorities and law enforcement a significant head start.
Lead time to maybe prepare for overdoses or tailor public health messages or focus interdiction efforts.
Precisely. If you know a new, potentially dangerous substance is becoming more prevalent before people start showing up in emergency rooms in large numbers, that's incredibly valuable information.
Yeah, that's proactive, not reactive.
Exactly. And it's why, as the study mentions, this kind of data is being incorporated into things like the South Australian Drug Early Warning System, say TWs, using wastewater as one input for rapid alerts.
Okay, let's circle back to phenibut. You mentioned it was detected very frequently, but it seems different from those cathinones like eutylone and pentylone that were shifting rapidly.
That's right. Phenibut was kind of consistently present at high frequency, 72% mean detection in capitals. But instead of swapping out, it showed its own trend. The amount detected seemed to be increasing over the study year.
Okay, first, what is phenibut used for typically? It's not a stimulant like the others, is it?
No, it's described as a neuropsychotropic substance. It's sometimes used recreationally. People report effects like euphoria or anxiety reduction. It's often bought online rather than through typical street drug channels.
And you mentioned it's actually banned in Australia.
Yes, it's a prohibited import and listed as a poison in most states. Despite that, the study found quantifiable levels in wastewater from every state and territory they monitored in 2022.
Everywhere. Were some places higher than others?
The study reported that the Northern Territory showed the highest average loads, so the estimated amount being consumed compared to other areas over the study period.
And it was increasing overall.
Yes, the total measured amount of phenibut in wastewater across Australia generally trended upwards during 2022, with the highest average levels seen in the final sampling month, February 2023.
Why is spotting this phenibut trend in wastewater particularly important? Does other data miss it?
That seems to be the case. The study specifically mentions that other Australian data sources on drug use, like surveys, show very low reporting of phenibut use.
So people aren't admitting to using it, or surveys aren't asking the right questions, maybe?
Could be a bit of both. But the result is, WBE provides this unique window. It shows phenibut use is actually quite widespread and potentially increasing, even when other methods aren't really picking it up. It's like uncovering a blind spot.
And that matters because phenibut isn't harmless, right?
No, it's associated with risks like dependency, quite severe withdrawal symptoms, and other side effects. So having this wastewater data is really important for public health to understand the true scale and trend, especially when other indicators are lacking. Continued monitoring seems warranted.
It paints a powerful picture. But like any scientific method, I assume there are limitations to this WBE approach. Did the study authors point any out?
Yes, they were careful to note a couple of important caveats. One is about the targeted nature of their analysis.
Meaning they were only looking for those 59 specific NPS?
Exactly. So if a brand new NPS, something completely novel and not on their list, started circulating during that year, this specific method might have missed it. Detecting totally unknown compounds requires different techniques, often called non-target screening, which has its own challenges.
So it's excellent for tracking the known threats, but might not be the first to spot something completely unexpected?
That's a fair way to put it. The other main point they make is about interpreting the quantity found.
The mass loads.
Right. While they can estimate the total amount of a substance consumed by the population in the catchment area, it's very difficult to translate that directly into, say, the number of people using the drug, or the average dose each person took.
Why is that difficult?
Because for many NPS, we don't have precise data on exactly how much of the drug or its metabolites a person excretes after taking a certain dose. And we often don't know what a typical recreational dose even is for these newer substances.
So the wastewater tells you how much is being used by the community in total, but not necessarily how many users or how much per user.
Precisely. It's a community-level consumption measure, not an individual behavior tracker. Still incredibly valuable, but important to understand that distinction.
This has been absolutely fascinating. This deep dive into the Australian wastewater study really highlights, I think, how we can use these, well, unexpected data sources to get a unique picture of what's happening.
It really does. Analyzing sewage gives us this timely, powerful, and sometimes uniquely early insight into drug trends, especially for these elusive NPS.
And the key trend here was so clear. That rapid shift over just 1 year, away from eutylone and towards pentylone and N N-DMP showing up in the wastewater.
A very stark example of market dynamics playing out chemically.
Plus that crucial early warning aspect. Seeing the wastewater data signal these changes before they fully emerged in hospital data or seizure reports.
It really underscores the value of this science for public health and community safety. It's about understanding what's actually circulating, sometimes hidden just beneath the surface.
It certainly makes you think, doesn't it?
Yeah.
If we can learn this much about drug trends by analyzing wastewater, what other insights about our collective health, maybe our behaviors or even environmental exposures, are just waiting to be discovered, flowing through those pipes beneath our feet?
That's a great question to ponder. A lot more potential there, I suspect.
Something to think about until our next deep dive. Thanks for joining us.
Thank you.